Thank you so much, everyone, for joining this session on an area that I've been digging into increasingly over the last year or so, which is decentralized identifiers and verifiable credentials. And what I would like to do with the next half hour or so is give you a sense of some of the challenges that I see in this space, and then a view onto some of the emerging technologies. And so I'm going to use this framework to talk through what I see as some of the primary challenges. Try to give you a sense of how this problem breaks down. But to say a little bit about the root cause, and this is something that I think all of us have as a consumer experience out there on the web, every time we begin a new conversation with an organization or another individual or system on the web, every time that relationship starts from a blank slate. So this could be me as a patient starting a new account with a new healthcare provider. Or with a new insurance company. We're trying to get my relationship with my insurance company to be something that my relationship with my healthcare provider is aware of. Every one of those starts from a blank slate, and that can cause a lot of user experience and management, as well as security challenges. So here's the three categories I think about, and we'll be using these to frame the discussion. First of all, there's questions of identity. Every time I start a relationship with a new organization, there's some question of, well, who are you? And this could tie back to who in the real world are you? So like which of these people in maybe the country corresponds to this user? Or sometimes it's a question of what qualifications do you have? So are you licensed to practice medicine in this state would be an example of a qualification. And then there's always this question of how do you present the information that you need to in order to bring that level of assurance around your identity. There's a related question of authentication, which is how do you sign into that system? How do you do that securely? And how do you sign in a way that prevents other people from taking over your account? So those are issues of authentication. And then finally, there's a category here that might look like a little bit of a grab bag, but I actually see this as a continuum that includes things like privacy, sharing, and transparency. And this all comes down to, as a user, how do I want you to manage my data? What things should you be allowed to share? With whom can you share them? For what purposes? Where should the data go? How can a user be notified when information moves? Basically, what are the things that I want to be done in order to protect my privacy? And all those things differ site by site and organization by organization. So I'm going to spend a couple minutes on each of these topics as we dive in here with a very simple thesis, which is that all three of these areas are at best highly disorganized and at worst pretty broken on the web today. So first, let's dig into identity, where first I'll argue things are a bit of a mess. This comes down to questions like, who are you? And in general, we've got a couple of approaches. One is some kind of in-person identity proofing step. So for example, you go to a physical clinic where you hand a card from your wallet across the table, and somebody maybe makes a photocopy or reads some of the details from that card and looks up at your face to see if they match. And then they create a new record inside of their system based on that in-person step. And a good thing about that process is it clearly builds on existing relationships that you've got with a healthcare provider organization. You've got this organization that you know in the real world, and they tie together your identity based on that real world relationship. The challenge is that this is incredibly slow and expensive and inconvenient. So in the best case scenario, maybe you're going to some place across town and you just drive on over as part of your visit. You get there 5 minutes early and spend a little extra time. But in the worst case, this is a place where you used to live, but now you live nowhere near there, and it's just not a good option to visit in person. And then the other challenge here is that every organization has a totally different process. They want to see different attributes of your identity.
Actually making me so sad that I couldn't go.
Oh,
it'd be like real cool.
I've got some folks in the background who are not muted, so if my moderator friends could help me here take care of that, thank you. So it's an inconvenient process. Outside of in-person identity proofing, there's a very common approach that's known as knowledge-based identity proofing. So these are workflows that often happen on the web, where somebody will ask you a series of questions. You know, which of these towns have you lived in, and what color is your Volkswagen, and how tall are you? Those kinds of questions. And based on your answers to those questions, the website will determine who you are, basically that you are who you say. And the nice thing about those workflows is that they can be fast and convenient. You can take care of them entirely online, and they just take a couple of minutes. But there are some very serious downsides to these knowledge-based identity proofing workflows. First of all, they happen to be pretty expensive. for relying parties. You have to buy a service that sort of takes care of this. And one of the reasons is that these services can do the best job if they can accumulate the biggest databases of information about people. That those databases serve as information that people can prove their identity with. And the truth is, those data that are used to prove identity are often guessable. So just because somebody knows how tall I am doesn't mean they're me. And they're subject to data breaches. So the larger the data set you aggregate, the more interesting a target it becomes for attackers to steal. And effectively, when you're using knowledge-based identity proofing, access to that database allows you to pretend to be anyone you want. And so there's a deep sort of structural challenge here to using those kinds of knowledge-based information for authentication, for identity proofing. And it also incentivizes a kind of data hoarding, where the people who can build the biggest databases can charge the highest premiums for use. So those are some of the challenges in identity management or identity proofing today. I want to say a couple words then about authentication. How do you sign in securely to a website? And for most people, the common experience across the web has been pairwise account management. So every website you go to, you make an account for that website. You register with a username and a password, and you do your best to navigate the conflicting and confusing password requirements from different sites. These people require that you have one of these 6 punctuation marks, and this other website prohibits those punctuation marks, and you have to sort of navigate your way. And there's sort of 2 places where people end up here after getting confused. One is that they just use a password reset all the time because they just can't remember their password. Or 2 is that they use a password management tool. So in that first case, with password resets, your password becomes about as secure as the reset workflow, which is often email or text messages, or using a password management tool, which can provide significant improvement to the actual entropy of those passwords. But now you've got another tool in the chain that people need to select for themselves and manage. The other very common approach that we see across the web to improve the security of these individual passwords has been 2-factor authentication or 2-step verification. There's a whole bunch of different workflows and apps that we're all familiar with here that really come down to, can we have you demonstrate something in addition to a password? So that might be a single-use code that's generated with a time-based key, or it might be proof that you can receive text messages at a certain number, and so on and so on. And these systems really improve the security of the overall authentication process. But from the consumer perspective, you need to get familiar with and basically use every one of those methods, because some organization you interact with uses app number 1, and a different organization uses app number 2. And you just, as a consumer, eventually you have all those apps on your phone if you want to be able to sign in all those places. And then the other major approach here to authentication has been single sign-on. So how do you rely on a third party, maybe a consumer brand like Facebook or Google, and use your account with that third party to sign in securely to other websites? And this can be very strong on the security side because these are companies that have dedicated security teams, very good practices, online monitoring, risk models, real sophistication around the security of that sign-in. So that's good. But on the negative side, this kind of centralization means that when you make an account with a healthcare provider or an insurance company, if you're relying on a consumer web brand like Facebook to sign in, it means you don't really have control over your account to that patient portal. You're going through a Facebook or a Google in order to sign in there. And that means that if you lose your account on that consumer website, you might lose your ability to sign into your patient portal. And it also very critically is a privacy challenge, because now it means that you're trusting that third-party identity provider to know about every place you sign into, when, and sometimes issues about why or what data will be shared with them. And that means that you can be tracked across the web, not just on the consumer tools that you use, but in the healthcare space, you could be tracked across the different healthcare organizations that you connect to. So that requires a very high degree of trust in those third parties. So authentication has been very challenging across the web. And then the third category that I wanted to talk about, which again, I think today is very inconsistent, is this issue of sharing and privacy and transparency. And I'll say here a couple of details that are more healthcare specific. And first of all is in the US under HIPAA, we have a set of allowable reasons to move healthcare data around, perfectly legal under HIPAA for purposes of healthcare treatment or payment or operations. And these are things that are legal but surprising. They tend to be opaque to consumers. And so when you hear in the news that your data are being shared by this health system with this technology company, those things can come as a surprise. and often a distasteful surprise for people who learn about these things. In theory, under HIPAA, individuals have a right to what's called an accounting of disclosures, which means that you can get a list of all the places where your data have been shared. In practice, this doesn't really work out that well. There are some escape hatches where if your data have been de-identified before they're shared, then it doesn't fall under this accounting of disclosures because they've been de-identified. Although in practice, data that have been de-identified can often be re-identified. So it's not always a meaningful protection, even though it counts as a legal kind of safe harbor. And then just nobody has developed convenient automated workflows for sharing these kinds of disclosures. So at best, you might get somebody to fax you a list or a mountain of paper that explains some details about where your data have gone. So there's a lot of places where data are being shared in ways that are surprising to consumers in healthcare. And then the most tragic thing is that often data sharing fails in the cases where it's most needed. Like maybe you're showing up at an emergency room in a place where you're just visiting on vacation and the clinical staff there could really use information from your healthcare history to treat you, and they don't always have it at their fingertips. It's not always easy to get that information to flow. And so we've had a couple of efforts at the national level to invest in these kinds of data sharing networks. The most recent effort there is called TEFCA, the Trusted Exchange Framework and Common Agreement. And there's been a lot of good work towards sort of making that practical. But under the hood, these systems all rely on what I describe as probabilistic patient matching. And there's no shared record across the systems. And so when somebody at that emergency room wants to look up information in your health record, they wind up sort of broadcasting a query that to say, I've got a patient named Josh who lives in this city. Do you have information about that person? And they might broadcast that to all the health systems, or they might do it in a sort of targeted way to say everybody within a certain radius. They would just send that query out and assemble all the responses. And this can be very powerful when you lack any other kind of data, but it means that clinicians need to be on the alert to false positives as well as false negatives. So you might get data back about somebody who has a very similar name to your patient, but when you drill into the details of the medication list, you need to be on the alert because that might not really be your patient. And similarly, on the false negative side, you might just be missing certain data because not enough identity attributes matched in this kind of broadcast query. And those details tend to be hidden under the hood of the system. So it's very hard to have visibility into when and where things go wrong. So that's a little bit of statement of the problem. And now I want to shift gears a bit and talk about some of the technologies that I've seen that I think could stand to make a real difference in this space. And I want to say a lot of this technology is early. It's not yet ready for convenient consumer adoption, but this is in many ways the perfect time to get involved from a standards and healthcare use case perspective, because this is the time when, first of all, we can start to leverage the technology, but we can also begin to shape it. So the first technology that I want to talk about here is called Decentralized Identifiers, or DIDs, as I'll use for short. This is being standardized by the World Wide Web Consortium. And at its core, it provides a method for kind of authentication and management of identifiers that puts control in the hands of individuals. So if you want to create an identifier for yourself, you can do that without needing permission from any outside organization. And you can tie or bind that identifier to cryptographic keys. So you can have really strong security around it, for example, by running a secure mobile wallet application that manages your public keys and that unlocks using something like Face ID or your fingerprint. And the nice thing there is that that lives under your control. And as you're using this kind of system to authenticate, you don't have to share that information with centralized identity providers around the web the way that you would with a single sign-on approach that uses an external consumer identity. You can manage this for yourself. And at the core, this idea of decentralized identifiers is very simple, which is to say anyone can create an identifier for themselves. And if I know your identifier, I can use that to look up what's called a DID document. There's a snippet of JSON on the screen here that I won't go into all the details of, but this DID document includes a list of your public keys. So if you tell me your identifier, I can look up your DID document, and then I can discover all these public keys, and in some cases, certain service endpoints that you've decided to register there. So it becomes a discovery mechanism, which is very flexible, but targeted for authentication keys and a list of services that individuals want to advertise to say, this is where you can go to request more information about me, for example. And at its core, that's what DIDs, or decentralized identifiers, are all about. And there's a variety of different DID methods that can be used that have different properties. So as a consumer, you can pick one of these methods, and within that method, provision an identifier for yourself. So that's a little bit about how individuals can control this kind of information. particularly making their public keys discoverable using DIDs. And on top of that, you can start to layer some very important capabilities with another set of emerging standards called verifiable credentials. So this is a data model that's been standardized, again, by the World Wide Web Consortium, focused on providing a way to write down information about a person and tie it back to them in a fashion that can be cryptographically verified. And so this works a lot like physical cards that you might keep in your physical wallet, like a driver's license, where, in that case, the state may have issued you this physical credential that has certain attributes about you written down on it, your height, your eye color, your street address, and the state signs off on those details when they give you the card. And then once you've got that card in your wallet, you can use it in all kinds of flexible and convenient ways without having to go back to the state or the DMV to let them know that you're using your driver's license. So when I present my driver's license to get into a bar, I'm demonstrating information that the bar can check, but I don't need to tell the state which bars I'm visiting and why. So it's a very convenient decoupling that happens between issuing these credentials and then an individual presenting those credentials. And of course, in my example, it was an authority like the state issuing these credentials. But using these standards, anyone, organization or individual, can issue credentials. And so it really democratizes the framework for creating these kinds of virtual identity cards. This is a diagram from the verifiable credentials specification itself that talks about sort of the conceptual model. What are the major roles in the verifiable credentials kind of workflow? And I want to focus on the top row here. There's three important roles to keep in mind. First is the issuer. So in my example, that could be the state DMV that's issuing you a driver's license. Second is the holder. So this is like an individual consumer who's going to keep that credential, maintain it in a secure application of their choice. And then the third important role is the verifier. So that would be, in my example, the local bar that wants to check my ID. When I present that credential to them, they're able to check it and make sure that it was in fact issued by the state without having to involve the state in that workflow. So those are the three key roles. The issuer gives me a credential and I present that credential to a verifier. So I want to then use this as sort of the basis of a case study to think about how we can deploy this kind of technology to serve something that is certainly top of mind for a lot of people these days, which is thinking about COVID-19. I want to provide some caveats here, which is this technology is still quite early. There's many different approaches to solving these kinds of issues in COVID-19. But I want to use this as an example just because it's something a lot of people have been thinking about recently. So the goal would be to put consumers in charge of keeping track of and presenting their own lab results. So you could imagine a scenario like an employee getting back to work after having been infected with COVID. And maybe the employer policy is that an individual needs a note from a doctor, or maybe they need to show a negative PCR test that was done a certain duration after they got sick. Or if we think forward to the future, optimistically, and say we can envision a time when there will be immunizations available that are effective to generate durable immunity, you could think about this kind of technology as a way to store an immunization record. And of course, this doesn't just apply to COVID. We could think about immunization records for kids going to school with immunizations we've been using for decades. But this core technology really opens up a lot of possibilities because on the one hand, we know that the clinical details are ever changing. So in the case of COVID, what lab tests are the most relevant? Which results should we be using to make decisions? This is really fluid. And so we need an approach that can keep up with the richness, or I might say the complexity, of some of those real world clinical and scientific details. I might have a test done at a certain date, but the interpretation of that result can change over time. And we want to make sure that we stay in sync with those changing interpretations. At the same time, it would be really nice if we could have a way to boil down some of those interpretations in ways that are use case specific. So if I'm thinking about getting back to the workplace or going to school or arranging for travel, there may be specific requirements or expectations that we would need to be able to present in those different use cases. And then very critically, we want to make sure that all the components of this stack are built on open standards and that the components themselves are substitutable, meaning that an individual consumer can choose which organizations and tools they want to work with while having a guarantee that the components will remain interoperable. So for example, there may be many different laboratories capable of generating results that you can store in this verifiable way. There may be many different mobile wallet applications that a consumer can choose among in order to securely hold on to their results. And of course, many relying parties. So it should be a very low bar to somebody asking an individual if they're willing to share some of these results. And then, of course, it's very important that we not require any kind of pre-coordination between the relying parties and the issuers. And so that means that anybody can just ask, hey, I would like to see this information from a consumer. The consumer can agree or disagree to share, but that organization doesn't need to get on board with every lab in advance. We can decouple those processes so anyone can start a verifier quite easily. So let's think about what happens today if I wanted to show some kind of laboratory result as part of a workflow, maybe for going back to work or for getting into a physical space. So today, maybe I have some kind of test done. And maybe that result is available from the testing center or the lab, available to me to download or access through a portal or a mobile app that the lab provides for me. And then once I download it, I can find some way to share that information. So I keep a GitHub repository with a lot of my own healthcare data that I just make public for folks to see, honestly, because I don't feel that private about most of what's in here, and because it can be very useful for software developers to see some real world examples. It can just be too hard to dig into this level of detail. So I've got a GitHub repo here where I make some of this public. It's linked to from the slides. So maybe I have a test done and I get access to a set of JSON like this that shows the fact that I've got a diagnostic report from a COVID-19 serology result that does not contain detectable levels of certain antibodies. You know, that would be an example of something you could write down by your JSON. Or of course, you could wrap it up into a PDF and create a lab report that looks something like this. Same basic information from what I showed in that JSON, but of course you're formatted in a printable document that might look more like what clinicians are used to seeing. And so then the question is, great, now that I've downloaded these files, I could share them. I could show them to somebody on my phone, or I could email these files, but there's a couple of real limitations there. One is, how does the person receiving these documents know that they're genuine? How do you know I haven't gone into those JSON files or PDFs and tweaked a few of the details? So that can be really painful. And then the other challenge here is just there's no process to guide me. I have to make it up as I go along. Will you accept this over email? Do I need to fax it to you? Is it okay if I just show you my phone and then put it back in my pocket when I'm done? None of that is sort of standardized or made routine. The other thing that you could do with this kind of data is provide direct access to your portal account. So if I've got a lab portal with some data in it, and the bar down the street wants to see some information, in theory, I could grant that bar access to data in my healthcare portal and just make that connection directly business to business. And as a consumer, I can approve that connection through the Smart on Fire OAuth process. And the nice thing there is this sort of guides you step by step through sharing. And the results can make it directly into the hands of the verifying party so they can tell that it's legitimate. But this can often lead to what I would characterize as a dramatic kind of oversharing of sensitive data. So today, maybe the only option I have is to share all my lab results, but the only thing I want to share is the fact that I had a negative PCR test on a certain date. So you're sort of coerced into oversharing. And the other challenge here is it requires this deep pre-coordination where every app needs to register itself with every lab ahead of time before you can request this kind of information. And those are both challenges that we're working on as a community to provide more granular controls and to provide more automated registration. But the truth is today, both of those things are much more complex than the workflow of just presenting a credential that you've already got. So how could we improve on this with decentralized identifiers and verifiable credentials? I want to spend a few minutes and cross my fingers and do a quick demonstration of some of this technology. And bear with me for a moment while I switch my screen share over to show you a view of my mobile phone. So I've got a very simple open source demonstration app running here on my mobile phone, which is hosted at c19.cards. And the idea is this is sort of a very low fidelity version of a healthcare wallet. Every time you reload this web page, it generates a new decentralized identifier for you, which is represented by this DID value that's displayed on the screen. Of course, in a real world app, you would never show this kind of low level detail to a consumer, but this is a developer tool. It's designed to give you just a hint of what the user experience might look like, and then full visibility into what's happening under the hood. So when I first load this web page, I get a message here that I don't have any health cards in my wallet that are related to COVID, but there's a couple of steps I could take to get one. And so what I'll do here is press this button here to connect to a lab using Smart on Fire. And the lab implementation that I have in this open source demo is a very silly and straightforward one that just automatically signs me in without asking any questions. So when I tap this button, that's what that little refresh stands for, is me signing into the lab. And now I'm prompted inside my wallet, do you want to share your identifier with the lab? And this is a prerequisite so that the lab can then issue me one of these verifiable credentials. So I'm going to say, yes, I want to share my identity with the lab. And then the lab returns a COVID card. In this case, it's a bundle of FHIR resources, and we'll talk about the data model in a little bit. But this card is represented by some conclusions here about me, the patient having passed through an acute phase of infection. So that's an example of the kind of workflow that could get a card into my healthcare wallet. Now that I've got this in my wallet, what happens? Well, my phone is off, I put it away in my pocket, I'm strolling about town, going about my business, and then at some point I come to a verifier, an organization that would like to ask me to share one of these kinds of cards from my health wallet with them. And so maybe this verifier displays a physical barcode by printing it out on a piece of paper and taping it to their desk. Maybe they have a mobile tablet interface where they show this barcode to me, but this barcode can be used to start the process of requesting that I share a health card. So when I see this barcode and a request to share, I might open up my mobile wallet, click on this barcode scanner button, and then scan the barcode that's displayed for me by the business that I'll be sharing my cards with. And then on in my health wallet, I'll get this prompt. Do you want to share this information with the venue? You'll be sharing your identifier, and you'll be sharing any COVID-related results here. And if I explicitly choose to share these cards, then my phone will make what's called a verifiable presentation back to the lab. I can turn off my phone, I'm all done with that part. And the lab will have access to this information here that's exactly the same information that I had in my own wallet, but it's been signed and passed along in a verifiable way. So they can check the signature that I added to my presentation, and they can go back and check the signatures on the underlying lab results to make sure that they come from a trusted lab. So that's a quick demonstration to show you a little bit about what the consumer workflow might look like. And from there, I want to dig in and talk more about what's happening under the hood. So I'm going to go back to just sharing my screen here. So the idea is this might be one set of technology, one kind of workflow that helps consumers do an explicit presentation of their own healthcare information. Under the hood, what happened when I saw that barcode? Well, every time a relying party, like the venue in my example, wants to ask for a verifiable presentation, they can create one of these links. It's a web link that starts with a scheme called OpenID : // And that's a convention that's been standardized as part of the OpenID Connect specification to ask for information to be shared from what's called a self-issued provider. So normally in an OpenID Connect workflow, that might be a redirect to Facebook or to Google to sign in with one of those external identities. But here it's a redirect to a local native mobile application, or native web application, I should say. Either way, in my example, it was a web app. And that local app is going to take care of the protocol for me. And so instead of outsourcing that job to a Facebook or a Google, I can use my own app running on my own device securely to scan that barcode and begin the process of deciding to share information. So on the response side, my app is going to read the request data. It's going to prompt me about the information that the relying party is asking for. So in that case, it says, somebody's asking for these particular types of cards from your wallet. And if I choose to share, then that set of credentials is packaged up in what's called a verifiable presentation, and it's sent back over to the relying party. So that's just a little bit about what's happening under the hood, but the pointer for folks who are interested in learning more on that front is a specification called DID SIOP. That's for decentralized identifiers. This is a self-issued OpenID provider, and that's the place where a lot of the community effort has been coming together to build on the OpenID Connect protocol and provide a way for these kinds of consumer-controlled identity claims to be shared. That's a little bit about protocol, and now I want to say a little bit about content. So what's the actual information that's being shared in a workflow like this? So the approach that I've been using in this space has been to try to lean on FHIR for the things that FHIR is best at. So those are things like clinical semantics, what tests were done, where were they performed, what kind of specimens were used, what were the results. All that stuff is the place where FHIR really shines. And then on the other hand, to use the W3C semantics where they shine. So those are for things like the credentials. who issued this credential? When will the credential expire? What are any restrictions on how it can be used? Those kinds of details are the places where the World Wide Web Consortium has really been driving strong standards to support those verifiable credentials. And I've got some examples linked to from the slide deck that can show you sort of how we're using these pieces together. And I'll just sort of very quickly scroll through it to give you an idea of the shape of one of these verifiable credentials. First thing I'll say is each of these credentials has one or more types. So in this case, it's a verifiable credential. It's a COVID-19 related credential, and it's a credential that's designed to be used in an online presentation. We'll come back and talk about that in a little bit when we talk about some of the privacy preserving characteristics that we want for these systems. So these are all metadata about who issued the credential, when was it issued, and then we get into what are called the claims. And so these are the attributes that somebody, in this case a lab, is signing off on and saying these are things that I have verified to be true about this individual. And so this is a JSON structure that can have any JSON you want. What I've done is to pack here a FHIR version, so we know what version of the FHIR spec we're working with, and a FHIR bundle. And so in this case, it's the FHIR DSTU2 bundle that's going to contain information about who the patient is, things like a name, a phone number, and this trust mark here, which represents the level of assurance I have about that person's identity. And then it's going to have a set of clinical resources. So in this case, a very small graph with a diagnostic report and a couple of observations linked to from that diagnostic report that represent things like serology results for IgG and IgM. So those are some of the markers that you could find in an individual's blood if they've been exposed to and mounted an immune response to certain proteins characteristic of a COVID-19 infection. So when we think about modeling these credentials in JSON using FHIR and using verifiable credentials, one critical decision is how do we tie this back to a user's identity so that when I'm showing my credential, a relying party knows, oh, this is really a credential about the person who's standing here in front of me. And at a high level, what I would say is the attributes that you want to show need to be enough to satisfy the use case, but you don't want to show any more than that because it becomes a privacy risk to overshare. So we want to be very careful in the way that we design what goes into those presentations. I won't spend the time on this talk to go into this bonus topic unless we have a dearth of questions at the end, but there's links to some thoughts about then how to summarize these results beyond just providing the detailed lab results. How do we provide actionable summaries to say something like this person has been infected or there's evidence this person hasn't been infected, those kinds of things. The last details that I wanted to share before opening up for questions and discussion is just to review the fact that these are early days. There's a lot of work being done on these core standards for decentralized identifiers and verifiable credentials. And then there's a rich set of technology being built up around those core standards. So for example, every time I decide to share data with someone, how do I keep track of that? How do I answer a question like, show me all the places that currently have access to my data? Well, a concept of consent receipts is something that could be very helpful there, where inside of my mobile wallet, every time I share one of my cards, my mobile wallet also might issue a receipt and store a copy of that receipt for me, so that in the future, I can review a list of who's got access to my information and maybe make decisions about pruning back that access if I realize that it's gotten out of control. Another technology that's super interesting is beyond just saying, I've got a mobile wallet where I can keep track of all these cards in one place on my phone. How do I think about providing access to a broader set of data, giving maybe a healthcare provider a place in the cloud that's under my control that they can write to in a way that's fully transparent and secured by these same kinds of identifiers. So there's a lot of work happening in the space of secure data stores or personal data hubs building on this core technology of decentralized identifiers. So again, it's early days, but there's work groups coming together between the W3C and an initiative called the Decentralized Identity Foundation to try to lay out some of the core standards there. So we've got just a few minutes left for questions, but I wanted to pause and open up to everyone. Thank you so much for your attention. Please share any questions that you've got here in the session's Q&A, and I'll make an effort to review this as we go. I see that I may have made a data permissions error on the slide deck, so I'll fix that right now and make sure that everyone's got access to the underlying deck that I've been showing. So questions from the community. go back to my questions list here. So there are a couple technical questions about just getting audio sorted out and getting access to the slides. Here's a question with the bundle that I showed with types. And the question is, are they extensions and are they registered extensions? So it's a great question. There's a high degree of flexibility in the underlying standards for verifiable credentials. Basically, these types should be thought of as full URLs. You don't need to register them in advance. So this is sort of what some people will refer to as enabling permissionless innovation or enabling an open world framework where anyone can add this kind of information and layer it in. And it's by making these types into full URIs that we allow this extensibility without needing registration. Syntax-wise, if I wanted to write something shorter rather than a full URL, I could use some additional features to register a set of those different types in my context. And if I register them up here, then I could refer to them by shorter names down here. But it's easier when you're first getting started with these specs just to think in terms of full URLs. So I hope that helps on that question. Let me see if there's other questions coming up in the session Q&A. Or if folks are able to unmute and ask questions here, that would help too. So here's a question about business drivers. What are the drivers that will push adoption of technology like this? Frankly, I think there's a few important aspects. I think that there's growing societal interest in putting individuals in control of their own data. We've seen regulations can be very helpful here. So GDPR in Europe or the California Consumer Privacy Act in California in the US are starting to lay out expectations that are much better aligned with these kinds of technologies. I think that consumers are beginning to expect this kind of tailored and explicit behavior on how their data are treated. Here's another question about how can we protect overloading our phones and devices as a holder of keys. So this is an interesting question because it suggests that maybe phones are not the best equipped devices to do this. I think there's an open question here. So over time, consumer phones are developing better and better capabilities for securely managing keys and for protecting access to those keys with biometrics. So actually there's some very strong technology there. That might be a good thing. There's also an increasing use of dedicated hardware tokens that can store keys. So the technology is sort of agnostic to that question of where the keys live, but the functional requirement is that they live somewhere that's secure and also convenient for an individual to manage. I think those are the real keys. And so a lot of early technology has been focused on the phone here as a place for that to live. Question is, are there any reference implementations for DID PSYOP? Yes, there are a couple. So Microsoft has one that has been recently released as part of its verifiable credentials toolkit. We could share links there. I have a reference implementation in my open source code base for the demo that I showed at c19.cards. And there's also a reference implementation that comes with the specification itself, although I don't know that it's kept up with all the developments. And I'll take one more question here, which is, are you seeing use of public permissionless blockchains in DID? And the short answer here is, yeah, there's a set of different DID methods that put different requirements on levels of decentralization. So there's some that just fall back to owning a website, and there's others that use permissioned blockchains and others that use permissionless blockchains. And so depending on what your needs are, there's some DID method that's going to be a good fit for those needs. So with that, let me pause here and wrap up. Thank you so much for your attention. I know that the virtual Q&A format can be a little challenging, so if I didn't get to your question, I will make an effort to go through the questions after the fact and answer back in the Whova platform. Thanks so much.